things that you have already been doing. NumPy is a famous library that people use all the time for encoding their data and running machine learning models using Scikit. You can start using TensorFlow with that same thing. We have normal operations as you see on NumPy, but there are some deep learning operations exclusive to TensorFlow that are here, sigmoid and ReLU, and like more of them. So TensorFlow not only provides you what you have been already doing, it gives you more on top. So any machine learning model that you have been using until now, you can use it, definitely. What you will get is an added bonus on top of running it deep in deep neural networks, right? And more things will come to that. So how does it look? You have a Python program, very basic. This is a really simple program to classify images. Yep. And this is the graph that computes out of that. So what TensorFlow does really well is it will take your program, compile it into a graph. Now at this point, you don't need a lot of machine power. At your machine, on your laptop, you can do this. Executing this graph or training this data, so data could be like, you could have 1 MB file or you could have hundreds of GBs of file. You cannot train that on your machine, alright? So what TensorFlow does is build this graph on your machine, and training of this data on this flow happens somewhere else. You can do that on Google Cloud, you can do that on your own machines. You can hook up multiple Raspberry Pis and do that on that. It will work. Right? So this separation of concern on multiple layers, writing a program to generate a graph. Graph is your execution engine, your data can live anywhere else, your execution, your training can happen anywhere else, gives the TensorFlow the ability to be the best of the frameworks that are out there. Because up till now what was happening is, if you want to do machine learning, you need a really good rig on your machine, like you need a good system, and then you run upon it, you need all the data there, you need big hard disk and everything. Nothing, you don't need, you can run this on a Chromebook, you can write the code. Compile it, push it out, run it on clouds, run it on Raspberry Pis, doesn't matter. Best place to run it is on Google Cloud, because they have TPUs. Alright, so what does a normal machine learning problem looks like? A normal machine learning problem, if you have done any theory around that, is basically trying to identify patterns. That's what machines are good at. So in this really simple example, we want the machine to understand that what are the points that form a pattern, and we are trying to fit a line out of these points. So I could have fitted a line like this, but that would be wrong because it won't get all the points closest to the distance between them. Okay, so I can explain multiple concepts right here. So when you are drawing a line, I could have drawn a line like this. What would happen is the error rate will be high. What is the error rate? Error rate is saying that whatever your machine learning model is, if I pass training data or testing data on top of it, how good it will perform. So if my line was over here, it will perform really bad because the point over here does not match to that line, right? The distance is really big. If my line was over here, some points will really be there, but most of them will fall off. So what you're trying to do is you're trying to maximize the number of points that will go on that line and make sure that you do not lose any. So this way what ends up happening is the overall error rate, that these distances between this line are in the least form, least distance. Okay, so this line that we drew is the least distance from each point available. So sum total of those distances is least at this moment. Okay, those are multiple concepts that we will go through. Okay, so to do that, how do you do that? TensorFlow programs really simple, but lots of code overhead. They are trying to make this simple. Right now, this is what it is there. If there's something better comes up, which is coming up soon, I can't talk about that, but yeah, as soon as it comes out, we will do another session on machine learning, and this lot of code is just initializing variables. You aren't doing anything. You are saying that give me a placeholder for x, another variable, and this is my formula. Alright? This is a lot of code just to initialize your code. They are working on making sure that this is easier to do. You won't have to do this. You won't have to do all of this, just this, and it will work. But yeah, this is how you build a graph. At this point, your system can do this very quickly. It doesn't have to do anything. Not a lot of computation, just normal Python code and compiling it back to machine code. Alright? Now this is the part where everything starts happening. Up till that point, nothing happens. This is the point where the machine prepares that graph to start executing. Okay, so you tell the machine, take the copy of this graph, and now I'll pass you data for this graph, and you'll execute this. The machine is getting ready to run this graph. And this is the point where you initialize that data. You put data into that model, into this graph. And this is the part where you are actually running the computation. Okay, the last line. So everything else is just setting up for that. This gives you, as a developer, lots of freedom. What you can do is you can try multiple of these types, multiple formulas over here, multiple ways of initializing over here. And you can run all of them in one single session somewhere else. You don't have to run all of this on your machine. Just compile a graph. What happens with that is, like, sometimes mistakes are easy to find if you're looking at a diagram of like whatever you have compiled. I wish there was a software which will take all of my code and draw a really good diagram of if-else conditions that I've written in my code. This does it for you, for machine learning things. Alright? Next, we talked about minimizing the error. Minimizing the error is, in machine learning, you talk it about minimizing the loss. Every time there's an error, machine thinks that's a loss for its own model. So what you try to do is just try to minimize the loss. There are multiple ways to minimize the loss. So let's say that these red points are where your loss is highest. Okay, so you're losing, let's say 50. Your distance is 50 from the center, from that center line. Okay, the sum total is 50. What you're trying to do is you're trying to minimize that. But when you're trying to minimize that, either what happened up till now in statistical process is you will see the result. Based upon that result, you will go back into your model and you will recreate that model based upon some parameters that you found out. But with deep learning, it changes. Because what you can tell deep learning or these machine learning, deep learning based models is how should it think about minimizing that error. Okay? So what it does with gradient descent is one of those functions. With gradient descent, it tries to find out least slope of where it should move. Okay? So least slope is basically saying it could move this way, right? But it won't minimize the loss really well. I don't know if this is visible pretty well, but these are like 20s numbers. But if it moves this way, this is 32. So it moves this way. Because it knows that if it goes this way, it will minimize the loss. So with gradient descent, what you are trying to go for is minimize the loss as steep way as possible. So you start the first time your machine iterations, your model runs, it's over here. It's really wrong. Okay? But in next iteration, it goes down. In next iteration, it goes down. So your model not only contains the base code of identifying the points, it also contains the code to understand where is it wrong, how do I rectify it. And based upon the rectification that you provide the formula for, it tries to auto-optimize itself. As it goes down, as the error goes down, you get closer to your whatever you were trying to find. Alright, so again, now what we did, we put that optimizer here. Just one line to put that optimizer here. This is the optimizer definition, and this is where I'm telling it to minimize the loss. This is machine learning. Really easy. You just need to know the function and just need to know the theory. TensorFlow gives you all of those functions pre-built. Just understand what you're doing, write the function, pass it proper data, and it will work for you. Alright, so again, similar to that, we first told it how to compute the loss. So how do you actually understand what is the loss? So we told that. Then we told it how do you optimize that loss. So this is the step, number of steps that it can take. So what could happen is you have this line, really hard to do this. So you have a line and you can tell it to move in small steps to optimize for that, but it will take a long time to optimize. Or you can tell it to take large steps. But what will happen is, if the line is here and I'm taking long steps, I will always keep doing the pendulum swing and never get onto that line. So you want to find a good fit. There are, like, you can again use machine learning for that even, like what should be my step size. But normally you start with a small number and like retune it based upon how you want to. There are techniques around this, but yeah, you start with some number. Then you tell the machine to minimize it. So always go towards the lower end. Alright? And then you again initialize the session, pass the variables. We are running it for 1,000 times. So we told the machine, try to do it for 1,000 times. In 1,000 times, it should be somewhere close to that number. Okay? So when we ran it our code first time, it took only one step. So if this is the scatter and it is trying to find a line, it will just draw a random line somewhere. It will be very wrong. But if you give it 100 tries, and every try it is trying to optimize the loss, finally it will find the line on which it should run. Right? Demo, yeah. No? Yeah? Come on. All
Yeah.
right. So, this is TensorFlow playground where you can do these things. Okay, so this is a really small example of how you would do. So rather than having a line, we have two circular things. Okay, so line is easy because that's y mx is equal to b. That's simple function. How do you do it for circles? Let's try to train our machine learning model. Ooh, nice. See what it did? When it started, let's pause it. When it started, this was the loss. Loss was really high. But as soon as it iterated, 194 iterations, most of which were like useless. I think I don't know how many were here, but around 50 to 70. And in 50 to 70 steps, it was minimizing the loss. This is loss minimizing. And based upon that, it is trying to identify where are the blue, where is the orange, and it found it out. Really quick example, if you want to try this out, go for it. I have a bigger example for you. Alright, oh, not this one. That's a different presentation. Alright. This one is a complex one for which I have saved exactly what the configuration is. So see the spirals? This is a hard problem. There are so many different ways, like it was circle was easy, because we have all things in the center. How do you point or plot lines around this? So let's see. Alright. See, our error rate is not dropping. It dropped really quickly, but it's stagnant. Like machine is really confused right now. What should it do? And then again, it drops. So these are the technologies that, not technologies, just the function that it is using. See, suddenly sine function is getting a lot of data in, and it's minimizing the loss, and spitting in, close, getting close. See these graphs, the way it is vibrating? Because it's trying to get real close to that, but it's not getting close, it's just vibrating. So it's doing all that randomness, but it is minimizing that again. Even that randomness is getting minimized. And slowly you see that it is coming close, around 1,000 steps, it gets close to that. See, at this point it's like, again stuck. It cannot do this, it's really hard. How does it know, like so much blue around here and such a little orange? But it's getting there. Ooh, around 1,000, it's good. At this point, see, these are the different layers on which this is like the deep learning part, where you add more neural networks, more neural layers in the middle to make sure that your model learns. So what machine learning gives you is the way your brain functions. So you do not remember things in your brain. That's how, like, this is not me, this is all the research that has been done. You do not remember exact things. You remember small parts of each thing. And connecting those together, you find out what that final thing is. That's how it works. It learns in this whole diagram. It tried to find out a small edge like this, a small line, a small squiggly lines, more squiggly lines. And as the layer goes complex, it learns better patterns. See, the patterns here are really straightforward lines. The patterns over here are really complex. And this is how it actually maps the final image. So with deep learning, what you are doing is trying to imitate what the human brain looks like. And this is like how we do it. And we already went through one example of fitting it to a line. It becomes a little more challenging to do it on a spiral kind of thing, or trying to find a proper image. But yeah, it's where you start. Alright? Next. How are we doing on the time? Ooh, just 17 minutes. Nice. Alright, so what makes TensorFlow good? There are lots of libraries out there, and I'm pretty sure they must be doing something good because they have been there for so long. Why is TensorFlow different? Why should I try TensorFlow versus any other library? First of all of them are going away. Just to give you a hint, Theano, the developer for Theano came up. Theano was the library which was used for all the research purposes on machine learning. The co-developer team came up. They said that after releasing Theano 1.0, which is scheduled in 2-3 weeks, they are not going to do anything more on that. They will support that, and they're recommending people to switch over to TensorFlow. Keras, which was the higher level API, which used Theano and TensorFlow as the backend, is now gonna only support TensorFlow, and I'm sure slowly they will merge back into TensorFlow. So not only it's making other systems obsolete, it's also, not only it is increasing its own pace, it's also making other systems obsolete. So what gives it this power? Why are people preferring TensorFlow so much? So it's all in the way that Google's engineer went behind that and designed it. So this is a really good description, and I'm going to take some time to do that. Alright, so all of your code that runs on these platforms, right? There's CPU, there's GPU, there's Android, there's iOS, your machines, and TPUs, which Google has launched, tensor processing units. All of that code needs to run on hundreds of different types of platforms. There could be Raspberry Pis over here, it could be a really old machine that you have lying around in your home, it could be anything, okay? So this is the layer where code actually runs. You should not care about this, because why do you care about that? You should care about how you write your code, okay? So this part is abstracted from you. That abstraction is done by TensorFlow. TensorFlow has an inbuilt distributed execution engine. What that gives you is, let's say you are training a model on your CPU. What would happen in normal cases or in other packages, you will have to install n different packages to run it on your machine. And when you wanted to run it on a separate machine, you cannot connect these two machines together to run both of that single task simultaneously on both of these machines. What TensorFlow did was add a distributed engine in there. So if you have an Android phone and an iOS phone and your machine in your home, you can connect all three of them together via network and run TensorFlow program on all three of them at the same time. So this way, it is using all the hardware that you can. What used to happen in earlier models, and even right now happens, is you will rent up big machines on cloud and you will use CPU. Or you will rent big machines on cloud, you will rent on GPUs. You are leaving CPU behind. You are leaving GPUs behind. Or you are leaving this third resource behind. Why not use all of those? With that, TensorFlow makes it really easy. Okay, so this is their hidden thing, not hidden thing, this is all open source. But this is the core competency that gives it this power. Then on top of that, they have Python support. Python is the language of choice. There was no really distinguished thing that they did over there. But what they made was, this layer is really easy to recode. So tomorrow, if you wanted to get TensorFlow based code, to write TensorFlow code in JavaScript, you can do that. There's a library already out there called deeplearn.js. It just uses something similar. I don't know if it is using TensorFlow in the backend, but it is using deep learning in the backend. So what this gives you is Python is supported by Google, C++, they are currently working on that. If you wanted to write your own executor on TensorFlow, you can write that. So it's giving you as a developer power to write code in your own language. So you are not bound by learning Python. Though Python, in my opinion, is really good because Python is Python. Okay, then on top of that, you get layers. Now you have written code. What up till now used to happen on the deep learning, other deep learning frameworks used to happen is building a layer was a manual task. You will have to write code for each and every layer. And that was really, really, I don't know how people used to do that, I never did that. But with TensorFlow, all you need to do is define that I need 3 neurons in this next layer and it will build for you. So making sure that you can easily scale your TensorFlow models into multiple layers. Because deep learning is all about adding more layers. It's not all about that. But it's basically add more layers so that your computation becomes easier. Then, even if you are not okay with doing all this code, it gives you even higher level models where the model is all built up for you. All you need to do is pass it data. Pass it data to train, pass it data to evaluate. Done. Simple as that. If you have used SciPy, Scikit, it gives you models like that, where you can say, give me a random forest model, I'm gonna fit it, and I'm gonna evaluate it. Those two methods. Simple. Last, canned estimators, all the models given already to you, the whole model is given, you don't even need to train it, you just pass the data to it, get the result out. I'm gonna show an example of estimator. Estimator, this is really new, not really new, but it's been around since the last TensorFlow Summit, which is 2-3 months ago. So what you do is, you pass in inputs and labels. You don't have to worry about writing the core code, writing that graph. You don't have to worry about how many layers should there be. No worries about all of that. What you do is, you take your input, you take your labels, pass that to an estimator. This could be any types of models. It will train it for you. For training, you use fit. Fit, remember, we are fitting a line to these points. Same way you are fitting labels to your inputs, passing it to an estimator using fit. Then you evaluate it. Machine learning is all about making sure that whatever you are trying to do, you can evaluate it, and based upon that you can learn and be better. So you evaluate it to make it better, or like understand how good the performance is, and based upon that you tweak other parameters. Then you use predict for prediction, because you want to make sure that all the models that you have built, you can actually use them. So use predict to predict that, and you can export it. You can export that model. This is like the really amazing thing about TensorFlow. You build a whole model, and in just one command, you have exported that whole model, and now you can put it on your Android, put it on your iOS, and start using it right there and then. Alright, what else does TensorFlow gives you? This is a visualization platform, TensorBoard. It comes along with TensorFlow. Your machine learning model was doing something. Because what you do is you pass it to data and gives you something output. But what is it thinking? What is it doing inside that? All those deep neural networks, neural layers, what is happening in those? TensorBoard, the visualization platform, gives you the ability to go dive deep into that. It will show you your graph. It will show you how your machine learning model was doing. Remember that graph we showed of the errors vibrating and everything? All of that is coming from TensorFlow. These are called embeddings. This is like a really neat concept around learning of a machine. So engineers passed machine some numbers, and automatically it identified those numbers as clusters. They didn't tell it that these are the cluster. So what it did was, like all the 5s are together, or the 7s are together, it automatically did that, understood that these things that look like something go together. So these are like embeddings. This is how machine learns. Alright, so TensorBoard. Then distributed, of course, this is like the biggest thing that I like about TensorFlow, that it's distributed. I can just run it anywhere. You can run it in a server form. This is somebody running it on Raspberry Pis. They have multiple Raspberry Pis. I think it's a stack of 4. Yeah, 4 and 4 cross 5. They are just running it on Raspberry Pis. Put your models up there, run them. Another one. This is like, yeah, this is the challenge that industry faced. Because of solving this challenge, this is really easily adoptable in industry. What happens in a normal startup or a normal company is you have a data science team and machine learning team, and then you have engineers who are gonna build that model. So your machine learning team takes in data, spends 6 months on that data, comes out with a model. That model is written in MATLAB or XYZ language, doesn't matter. Then they pass it to your tech team. And now the rest of your tech team, which are normal engineers, they're going to write that code again in Python or any other language that they can actually use. And then they're going to put an API layer on top of it, and then it will be able to actually interface with the actual requests that are coming from outside. Really hard process. 6 months spent over here, 1 or 2 months spent over here. If something goes wrong, you have to again go back and forth, lots of time taken. TensorFlow gives you ability to serve right after you finish. So you take your data, you add a learner to that, you train your models are ready. This you can keep doing multiple times, iterative. There's no time spent between this learning process and this model generation. Remember that code estimator, you just have to pass one function and it's out for you. Then there comes the serving part. You put your model here into the TensorFlow serving, starts just ready at that moment. As soon as you put your model over there, it gives you an API endpoint, start an API endpoint, pass your images if you train an image model, and start serving that. Already at that moment. So what you can do, or what people do, or what I do in my company, is we have data, learner, all of this part where your team will do multiple times. Every day you come in, you get some new data, you try to optimize your models some way and get the models out. As soon as you get the models out, add a continuous pipeline over here. This model will go over to TensorFlow serving and it's ready to get out, and you can test it at that moment every day. This iterative building process is what industry was lacking in deep learning. This was the reason that researchers spent years upon something, they came out with it, and still there was a lot of lag before it went into production, and people realized that it is not really as good as they talked about it. Then they have to go back, retry this whole thing. If you build this process as iterative as possible, as quickly as possible, as easy as possible, research goes faster.
For the first step, data learn model 2 and model 1, maybe they have different patterns. So you can put them together or?
So what TensorFlow serving will give you is, let's say you name this model 1, it will give you an API endpoint slash model 1 slash, if that's model 2 slash model 2 slash, and then you can query upon that. So it automatically generates those different endpoints for you. It's not like all of those endpoints go up to the same one. They will go up for different ones. And then you can start using request. Alright, so who's using this? There are lots of companies which are using it. I use it, but other companies are not so eager to share their data, so we are going to use Google's. So they have put this out. Before TensorFlow was released internally, there was some interest in that. This is 2012, and this is around the time 2014 Q3 when the TensorFlow was launched. You see, there was some interest because machine learning is the thing that people have been trying to work upon for a long time. Until the launch, interest was low, growth was slow. But as soon as you launch it, since the iterative process becomes easier, everyone can do this. Like, this is normal Python code, come on. You don't have to do anything. You don't have to worry about all of these things. You can train multiple times. As a web developer, I started my job as a web developer, and the thing I liked about it most was I can switch the CSS hash 333, reload the page, I can see color change. I can do DDG, change, refresh the page, see the color change. That gives you the high speed of iterating. And as you increase this high speed of iteration, the result becomes better, always. So this is like the lean methodology, all the startups, everyone talks about this. Just make sure you put out your products, learn from it, build it again. All TensorFlow did. And then the growth is so big. Like, all these models, translate models, used to be handwritten models. Now all of those are machine learning models. Just one more thing after this, what they did was, now they are doing it, is called AutoML. It's training machine learning models using machine learning. So even data scientists or the machine learning experts who were there at Google, or are there at Google, writing these machine learning codes, they are trying to even replace those. So what happens with that is a machine is now doing all of this retraining process. I wish I had an image for that. But it basically has n number of different models. It trains on that, finds out which model is working best, and uses that model to retrain other things by itself. If you go online, search for AutoML, you will find that. Alright, demo of the day. Ooh, nice, 30 minutes. So we'll first talk about what this is, and then we'll do the demo. Alright, so that was all TensorFlow, who is using it, how they're using it. This is a demo that we will do. TensorFlow also provides you the ability to use the code that was written by somebody else. You can use that code, of course, you have always been doing this in the open source. But what happens is, once somebody generates a model, you cannot easily change that model. This is up till now. If somebody gives you a model, like let's say, Google has an API for image recognition. If you pass it an image, it is going to identify what it's being trained to do. You cannot retrain it. But TensorFlow gives you the ability to retrain a model. So if you have the raw model file, you can retrain that model based upon your own needs. Well, how does it do that? It remember that image. We are going to the very beginning. This is multiple layers of the model that anyone puts out in open source. Okay, multiple layers of the model. What you do is you remove this last layer. You remove that last layer, retrain that last layer. This whole model, this is like a really simple model, but let's say this was a normal image recognition model, it will take weeks to train that, based upon hundreds of thousands of images. Okay? But what you do is, with transfer learning or retraining, you remove that last layer. You remove that last layer, retrain that last layer based upon what you wanted to identify, and it will work for you. So let's see that in action. Alright. Alright, all of this code is available on GitHub, so don't worry about it. Don't save. It will work the same way it's working on my machine. It will work the same way on your machine, on TensorFlow. Alright, so we have this project. This is a project that is on GitHub, and like I'll show you the URLs later. What we have here is images in this categories folder. I have 3 different types of noodles. All right. There's carbonara. See this? Let's move this down. This is carbonara. All right. Multiple images of that. There are 100 images of carbonara in this folder. This pancit, 100 images of pancit in this folder. Okay? Don't get hungry, we have pizza. There are 100 images of ramen over here. Alright? We have a model from Google which was made open source. It's called Inception. That model file is in here. I'm not going to show it to you. It's really big. My browser will crash, my system will crash. Like trying to load it, it's not anything else. What we have is our test images are here. We are going to train our model on these categories, these 3 types of noodles, and then we are going to test it on these images over here. Okay? And we will also do some other things. But first, let's get started. So all you need for this is install TensorFlow on your machine. Find out that link, go to tensorflow.org, you will be able to install it. If you cannot do that, I'm really sorry about it. Yeah, you should be able to do that. If you can't, just like talk to me. Alright, so zoom in. I was editing this code last night. So I'm gonna run this code right here. What it is saying is, I'm gonna create bottlenecks. This will be the last layer that I'm gonna retrain. I'm gonna train it for 500 times. Everyone can see that? No? Big. Yes? Good? Okay. So first line is like, this is the file that I'm gonna use to retrain that has all the code. Second, bottleneck directory, it's the classifying, taking those images and making small chunks of those images. It's this machine learning process. This is how you will pass your data in. Next, I'm training it for 500 steps, 500 times. Remember that was 1000, and there was 40 or 80 something. And then I'm gonna pass it a pre-trained model. That's Inception. Third time I'm passing it the model. I'm gonna save all this modeling data so that I can show it to you of how my machine was doing over time. That will be going into this summaries directory. We will have an output graph. The graph, remember, not the model, the graph. That is the graph which we can run again. And we will have output labels, okay? And all of the images are in the categories directory, okay? Let's train this. I wish there was, see, I did not give it the path to TensorFlow, so I'm going to do that. I always do this mistake. Py-env, py3, bin/create. Alright, now it knows where the TensorFlow is. Alright, that's the same command. Did I press enter? I did. Alright, so this will first get the model. So these are the normal warnings. It's telling me that if you have GPUs, you can accelerate this training process because it can use GPUs and CPUs together. Right now I'm letting it run on CPU because my machine doesn't have GPU. It's now creating this 100 images on each directory. It's trying to train that. See the accuracy? It started at 50 something and it's already at 96, 98. It's like retraining that step multiple times. It will do it for 500. In each chunk, it is doing 100. It runs really quickly. See, 97%. See, it is vibrating 97 to 94, 98, but getting closer, 99, 97, 100% accuracy. Again, remember, this is all based upon the data that I provided it. The test data is still not there. This is machine retraining on that whole data by itself multiple times, so it can find out the best possible outcome. Okay, it's retraining. See the cross entropy. This is another way of understanding your difference. How far are you from your actual point? The one I showed you earlier was gradient descent. There's cross entropy. There's multiple of these. There's ADA optimizer, lots of those. Okay, nice. Final test accuracy was 97%. Let's see how it does against our images. So for prediction, you take this code and you pass it the file. So what we are going to do is, in our test folder, we have some files and we will pass it those. So let's see. First, I'm going to ask people to tell me what this is. What is this?
Ramen.
Ramen, nice. People know this. Let's see if machine knows this. Alright. So see the difference. If you were to do this on Google Cloud or any other hosted machine learning platform, it will be really quick. this is my machine, it's slower. So don't serve machine learning models from your machine. Serve it from somewhere better. See that score for ramen? 99%. Woo! It recognized that it was ramen. Alright, next one. Oh, from over here. Let's see. S/3C. What is this image? Alright, what is this one?
Carbonara.
Carbonara, nice. Let's see if machine can recognize that. Again, don't serve your models from your machine. Put that on cloud, Google Cloud. Alright, Carbonara 96%. Still not impressed. Just Carbonara. Alright, last one. Not last one, we have more. Screenshot one. Let's see, screenshot. What is this?
Pancit.
Nice. We have some noodle experts here.
I love noodles.
Yay, me too.
Long life.
Just ramen though.
What?
Alright, Pancit, 80% accuracy. So our machine model that we trained is doing pretty good. Let's see, these are the images that I knew that it was going to perform upon. But what I did was, I went to restaurants and I got myself some ramen. This is really big file. So I took those images, I posted them on Instagram, you can find it. You're gonna use live images. Let's go good code over here. Alright, so this is the image. Oh, not this one. This is the way I'm confusing the machines. We'll come to that. Insta ramen. This is from my Instagram. This is ramen that I had at a restaurant. Alright, we're gonna try that. Insta ramen. These are the real life examples. This is a really big image. And it's gonna try to identify from that image. What is it? I know that. It's not using the file name, just to make it clear. It's using the machine learning to find what it is. Ramen 99.7% accuracy. Alright, let's try to confuse our model. Let's first give it something which is. Can you tell what this is? Yeah, it's not carbonara. But let's see what our machine will tell us. 6387. So, since we trained our machine learning model only on 3 categories, carbonara, pancit, and ramen, it doesn't know anything else. So it will try to classify whatever you gave it into one of those 3 categories. So it went really close to carbonara, but it looks really like carbonara, but it's not that. It's a spaghetti. I don't know what's the difference though. Maybe I'm not a notified. Alright, what is this?
Whoa.
Is this noodle? This is just me eating chunk. So, there's chips in there, there's fried rice, there's chicken in there, there's some stuff on top, and there's my dog in the behind. Yeah, let's see how it does with this model. 5909. Oh, no, that's not possible. Alright. We'll try to go somewhere. Where will it go? Where will it go? Come on. Whoever guesses it right. Dog. I did not train it upon dog. Come on, it cannot exist a dog. It doesn't know that a dog exists. It knows only 3 things. Its universe is only 3 things.
All of the above.
All 3, but for which side it will go for? Side. That. Let's see. 73% pancit, 23% ramen.
That is not pancit.
This is the part where we go back to presentation. Alright. So see how easy it was to train or retrain a machine learning model. So what TensorFlow did, not only for you, but for everybody else, not only for the machine learning experts, not only for people who can write that code, but for you as a normal developer. You can take this code, go home, find out 100 pictures of you, find out 100 pictures of your friend, put them in a folder, train it, and next time your friend is on the door, make sure they stay there 15 minutes, you take a photo of them, make sure it recognizes, if it recognizes, then only open the door. Please don't do that. They will hate you forever. Alright, so this way, it gave the possibility of using machine learning to everybody. And when you make the technology accessible to everyone, that process becomes better. Tomorrow, let's say some of you found out that this model, I can actually retrain that or find out something, some accuracy in there. Because we sparked your interest, and now you're gonna go back and find it. Things to remember now on machine learning, which is like a really big topic these days, is all the biases that we put into these machine learning models. This model was based upon 100 images that I created upon. Okay? So if those, remember the quick draw thing that we were playing earlier? Some people were drawing cars different ways, versus somebody else was drawing that same car in a very different way. These are biases that we as a human tend to possess. And all these machine learning models that we built, they are a reflection of how we do or how we understand this universe. Make sure to question your biases. You are always doing that. It's not, you can never say that I'm not putting a bias into this model or in this task of mine. You're always doing that, knowingly or unknowingly. Just make sure to question your beliefs. Make sure that whatever result you got, re-question it. What was the thing that I was thinking when I was building this model? Is there some possibility that I'm not considering something? There's a really sad example of this. Somebody posts this online is soap dispenser. A soap dispenser works fine if your hand is white, but does not work if your hand is black. That's a really stupid way of doing that. So be sure that you know what biases you are putting into your machine learning models. Alright? And that is the point where I'll leave you. But for next step, if you want to learn more, go to tensorflow.org. There's a deep learning course on TensorFlow. There's a Stanford course which is online. There's a Udacity course. And if you're totally new to machine learning model, Josh Gordon, who couldn't be here, he does recipes, and go watch those talks. These slides will be shared. Want to take a picture, go for it. And I will be open for questions. And for 15 minutes, nice, I finished it. Yay! All right, questions? Go ahead.
So how does TensorFlow know
Okay, how does TensorFlow know if it is overfitting? Again, machine doesn't know anything. What you do is, we trained it to fit closely, to minimize the error loss. In there, what will happen is, when it overfits, it's up to a human to decide, or you can have some machine learning models in there, which will try to identify if it is overfitting or if it is very wide. So, again, there's always some human judgment that comes up in there. There are not a lot of processes that are defined around that. There are some best practices that you can use. Make sure your data is large enough, your data size is large enough, you are training it multiple times, training it on small chunks. Like a really good example is, we do not train it on one full image. What you try to do is, you try to confuse your model. So, if you have a chunk of 100 images, you pass it 50 images, and next time you don't pass any of these 50 images, try another different chunk. So if it learns something from that, something very special, it again in next turn when you try that again, it forgets that and learns something different. Not 100% forgets that, but part of that. The same way a human learns. If you always show a kid an apple and an orange and train it on that, for life you will understand that this is an orange. You won't know the difference. So what you try to do is, you try to introduce different types of examples. There was a really good Twitter thread on this, that a person was trying to teach his kid about what is the difference between raspberry and blueberry. So there were big sizes, there were small sizes. Make sure your data is very diverse. There were on different angles, on shades, on shadows. Just make sure that your data and your model, you're not putting any biases in there. Biases come from everywhere. They come from data, they come from the model that you're using, they come from the retraining techniques that you're using. All of those can make that difference. Yeah, it's like you will have some human judgment in there. Alright, next, yeah.
So, based on what you said earlier, do I have to randomize the data that I'm feeding in as I'm training it?
Yep. So TensorFlow again gives it to you. What you do is, when you put input layer in this TensorFlow model, you tell that I have 100 images of corpus of 100 images, like there are 100 images in this folder. Randomize it. So what it will do is, it will pick, let's say 10 images, or 50 images, or 100 images, but it will splice those images. It will make an invert of that image. It will make that image more pixelated. It will make it more granular. It will make it black and white. It automatically does these things for you, so that you can train your models better. So it will try to remove biases that you as a user might be putting those in. But again, it's not perfect. You as a user has to make sure that you are giving it proper data. So there are functions in TensorFlow that you can pass, like passing images, shuffle it, make the flip images of these, make all these things, and it will do it for you. You don't have to manually go in and find out the formula of flipping an image. Okay? Next. Yep.
I'm just curious, how big is that model file?
How big is that model file? I can find out. It's not small, but let's see. Find in folder. This is the pre-trained model. Oh, not find in folder. Just reveal. Reveal in Finder. This is the file, 88.9 MB, and this is the graph. Graph is 95.7 MB, and the model as a zip file, it's 88 MBs, and as if you export it out, it's 95 MBs. 95 MBs. Again, there are you cannot put this 95 MB onto your app. It will become really hard. So what you do is you reconfigure this model to go on export function, and with export you can pass that I'm putting it on Android or iOS. It will again recreate that model based upon the architecture, so it is optimizing for the machine level code, and it will give you a smaller model. So if you recreate this for Android, it becomes 17 MBs or something, and then you can put it on your app, put it inside your app.
So once you have the graph, how does it
Yep. Alright. Yep. Very good question. When you have the graph, how does it do the distributed part of the computing? So it all is in how you write your code. So let's go back. While you're writing the code, remember if you were writing a code in Python, if you were to write this code in Python, you wouldn't need this part of the code, right? You would just need a variable x, you will put it a value, you will need a variable y, b. You don't even need to define those variables in Python. You can just like x is equal to 10, b is equal to 5. Doesn't matter, it will do it for you. These things that you are doing over here gives the ability for TensorFlow to understand how you are fetching your raw data. So when I said this is a variable, this means that this is the thing that machine is gonna train upon or try to train upon. And this is a placeholder. This means that this data can come from anywhere. So what you did at this moment while defining this graph is you said that x is my placeholder, and this placeholder will get data from n number of locations. So data can be coming from anywhere else. Machine at the graph at this point knows that I don't have this data, but this data will come from somewhere else. I don't have to train my model to optimize for that, but I have to train my model to optimize for these. So lots of concepts behind this. It basically how you define your graph, it understands whether to keep it on this machine or to keep it on smaller machine or to source this data from network, from hard disk, all of those things, based upon how you define it. That's why this part is important. But it makes it harder for developers to get on board quickly. So they are working on this part to make sure that it's easier for other developers to come on board. Because even this part has like lots of things to learn in there, like what's the shape, what is the data type, all of the things you are defining beforehand, and you need to know before you are doing that, because you need to know where your data will come from. They're trying to optimize this, but yeah, not yet. Go for it.
Okay. Let's say I wanted to design this killer app that classifies.
Everyone wants to do that.
So I want to classify noodles, right, on an Android app. And you already created the model for the app. Okay? You export it, you give me the model. And
It's open source, it's available.
yeah, so I outsource the development of the app.
Uh-huh.
Android app. But this only supports Python, correct?
Again, all of this code that you ran, it will compile into machine that you want it to run upon. So there's a code lab on this which you can run on your own time. It will basically say, take this model which is supposed to run on my machine, compile it back into, or export this model into a form that I can run on Android. So this 86 MBs or 96 MBs compiles becomes 17 MBs. It's made sure that it is, like, make sure that you are passing the proper parameters that it is running on Intel or ARM. Based upon that chipset, it will optimize that model for you. Go, next.
So that's an Android, okay.
Yeah, you can just like make sure that it runs properly on your, just export function, just simple things. Yeah, not complex, nothing complex over there. More questions? Yeah.
How do you determine the good number of layers of neurons?
Yep, that's a really challenging question. Let's see in the playground. So here's the playground. This was the one that we did, but let's say if this is the one that I'm gonna do. Okay, so this neural network that we made earlier, was good to classify this example, or this problem. Okay? But as soon as the problem changes, how do you determine whether the functions that we're using earlier are good enough or not? So let's try first training it on that same thing. Ooh, really nice. It did that automatically, but most of the times it won't happen. So it's multiple try. What you can do as a human is you can try increasing or decreasing these layers. So if I were to use the same step to classify this, so what I had earlier was pre-trained, like I had a proper link which I was using, but if I want to do this right now, let's see if I can do that. So I'll wait for some time. If it goes above 1,000 iterations and it's not optimized, you are doing something wrong. So doesn't seem like it's gonna fit. I'm gonna add one more layer here, one more neuron here, and I'm gonna add one more neuron here. Let's see. So this is you increasing the layers, but again, some people think that as many layers you can add, as many neurons you can add, you will solve the problem. Not true. What you might be missing is the formula, the code formula that you are using. So what I did was, I made a change to the formula. Again, these are iterative processes. You will learn based upon when you are doing these things. Okay? This is the problem that is being solved by AutoML, but these are things that you learn over time. So now it's trying again. Seems like it can divide it into quadrants, but yeah, getting closer. Maybe this is a better one. The one that I was building, it had 6 or 7 neurons over here and 3 neurons over there. This is good enough, but not as good as we would like it to be. So you again try that multiple times. You can add more layers here. It's all right now a human judgment based. You try and see how your model is doing, and you optimize upon that. This is what Google has been experimenting in-house, and they showed this at the October 4th event. They do an event on October 4th, basically where they launch their phones and everything. And if you go search for Made by Google October 4th, you will find that video. Yeah. Sundar Pichai is doing a demo around how AutoML is working in-house and how their engineers are building something that has an accuracy, but AutoML automatically by itself, since they have so much compute, so much data, by itself is learning on those models and performing better than humans already. Like if you pass it more, it's going to be so much better. So this process is hard for us right now. This is the hardest part in machine learning as of this moment. Earlier it used to be coding this whole model or the data. Now you have so much data. Like we all have so much data. We do every time I tweet one thing, I know that there's a big list of JSON that goes through there. Yeah, there's so much data available. There's so much compute available. What is our challenge right now is this figuring out how many layers, how many neurons, what function. And these are the challenges that Google is taking on in their in-house. Maybe this will come out someday, but not available as of now. They have given you the library, the tool to use it. Hopefully someday they will come out with that as well. Right, next question. Go ahead.
The roadmap of this one, can you use this one in the KTV or FVR to test in the line or what?
That's a really big challenging problem. Am I lying? I don't know. This is like, I don't know how to tell this, but Hollywood and these movies has glorified that machines can do so much. It's not true. Machines can't do so much.
Yeah, they can.
What was that? It zooms into the number plate. On the number plate there's a screw. It zooms onto that, finds out the person has a watch reading in that, finds out the time, finds out that. Doesn't happen. There's a limit on which you can zoom. You cannot go, there are no pixels there. Where are you zooming? So please don't take those as the endpoints. Don't optimize for that. You can't do that. Okay? But there are possibilities. If you have enough data, I don't know how many of you have seen this, but there's another transfer learning code out there where it tries to understand an art form and applies that onto an existing image. I don't know if I can show you that. Let's see. We will keep doing this until other people come up here from the other room. My talk is already over though. Let's see. Nope, not over here. Remember that app? What was it called? Figma? No. There was an app where people used to take their selfies and then put an image on top and it would look like from Van Gogh images. I don't know, I don't remember the name. Does anybody remember that?
Yeah.
What was that? I don't remember the name. Yeah, so that was using basically
No.
They created an app out
It was
of
an
that
app, yeah.
model or that process. What it basically does, it takes an art form, understands how that art form was built, takes a normal image, and tries to apply that art form onto this image. So it can do that, it can merge those, but not as well. It can draw by itself.
Deep Art IO.
Deep Art IO?
No,
Okay.
it was something else.
I know that there is an Android app for that.
I forgot what it was called.
Deep Dream, that's the one, Deep Dream.
Deep Dream.
Let's see. Deep Dream Generator, yes, this is the web app. We will just go to galleries. Deep style. What? Load something. Okay, see this? Normal image, normal person, a styled image. And it learns a style and tries to apply that style onto the original image. So you get a styled image. And you can do this with different types of images. So there's a really good example by somebody out there. What they try to do is they feed a machine all the sonnets by Shakespeare, and machine writes out a new sonnet for you, a new story all by itself. There's a movie being made all by machine itself. They fed different types of movies to that machine. It tried to learn from those movies and try to come up with a movie on its own. And they are presenting that somewhere soon. Yeah. More questions? Machines are learning. They are going to take over, definitely. I just don't know what I will do then. Yeah. More questions? Questions. I have a question for you. How did you like this talk? You don't have to like what just put thumbs up. Alright, I did good. Bye. I'll take that. Alright, so we are all done over here. What I would suggest is, make sure you learn. This was the form for tokens. Do we have people coming in from different next one? No. I'll keep the open online. And I'm open for questions on anything. Not just anything, I can't answer all those topics. But anything that you want to talk about for today's event. Go ahead.
You know, like the video intelligence API.
Yes.
That's gonna be like accessible.
It is available.
Is it available?
Yeah. It was in beta, now it's available. Yep. It's available online.
Sandy, where are you going?
How did I get all that good pizza? I made an order. To Uncle Wade's Pizza. Yeah. How do you fund it? That's a secret. You don't reveal your secrets. I can give you the model. I won't give you the data that I trained upon. Alright? What else? Other questions? All of this code is open source. We will try to get all the slides from other speakers, put them on open source as well. Go ahead. Yeah, I can show you the number of images in there. It's online. Come on, go to GitHub. You can find the number of images in there. Yeah. It will, but it doesn't matter. I'm training it on 3 different images. Like, it's not really hard problem to compute, to find out 3 different things. But if you add more categories, let's say you added 10 different categories, and your images were still 100, it will become harder for the machine. Then you need to add more data.
So you need more images per class.
More images per class. Yep.
You had some bootstrap model to start training. What was that called?
It's called Inception version 3. Inception.
And does Google publish a bunch of these types of models?
Yes, they do, or they try to. So Inception is the most famous one, because it's image, and people have been trying to do image recognition all the time. You see it in Tesla, you see it in all the cars. It's like the most famous one. Another one is understanding human language, the way we form our sentences. That model is called Parsi-McParse-Space. It was British who came up with that name, Parsi-McParse-Space. So what it does is, you pass it a sentence, it tries to identify how you actually made that sentence. To classify what are the nouns, what are the adjectives in there. So that model is used in chat-based systems. You can use that to understand what a human is saying. So if I pass it, give me all the posts today for DevFest, it will find out post, it will find out DevFest, make a search online, that's not the part that it does. It just identifies those things, then you can add your code on top that will search online, find out those images for you. But it identifies the text that a human is speaking. So that is another famous one. I don't know others, but there are more coming in, and they are always revising these. So Inception, it's on version 3. There were more before that. Go ahead. Inception, again, modern. There's nothing in a model to make open source. It's like, this is the model file. You don't know the code that was written for it. You don't know the data that it was trained upon. It's just the model. So you can use that model. You can call it open source, but I don't call it open source. Open source is when you not only put the result out, you also put the code out, you also put the documentation out, you also put all the resources or the processes that you use to do that. And that's not what we are doing. No. Inception is trained by Google on all the images, or I hope all the images that they have in store. So millions of images, it was trained on months, and then they put out that model outside. What we did, we removed last layer of that. We removed last layer, last classification layer, and trained it again on our images, and now it can do better. It can recognize things that I want it to recognize. But if you want to use Inception model as is, you can use that. Pass it an image, it will try to identify this for whatever it has been trained upon. Similar, yeah. But
just a question about performance for like real-time applications, video, but also things like gesture recognition.
Yep. So again, this is my machine. Don't use your machine on real time. Like if you were running my machine behind a Tesla, you will never be able to be successful. So what happens is, the ability of a model to execute becomes better on the system that you are running it upon. Okay, so if you think of right now, if I have 97 MB of information that I need to compute when you pass an image and to give you an output. What my machine is doing, it's passing that into RAM, getting it back into memory, passing it into RAM, getting it back into memory. These are the processes which are hard, but as soon as you add more compute layer to this, it becomes easier. All of that data can live at the same time in the RAM, and it's even better if it is living in a GPU. In the CPU, it's even better if it's living in a GPU, it's even better if it is living in a TPU. So as you increase the lower level or the hardware, it becomes faster. Plus there's also another thing, like if you have your data encoded, if you are passing the proper data, what I would suggest is compare this against what Google offers as Cloud Vision API, and you will see the difference. And there are again more models out there which are doing object detection, which is similar to what you would say gesture detection. And those models can do it in real time on your machine, but like it will heat up your CPUs and everything. And
I guess the question is it practical today? Whether
yes, it is.
Okay.
It is. Tesla is doing that. Waymo is doing that. Waymo is a company that Google runs, the self-driving car company. Or I don't know if the rocket that SpaceX's landing is doing that, but it is doing some calculations based upon which it automatically identifies how much thrust it has to do. So it is doing some calculations. I don't know if it is using image recognition by itself, but I think it should be using, or it can be using geo coordinates of I still love you. What is that? Of course, I still love you. That's the platform on which they landed back. Okay, more questions. Why are those guys still not here? But
So with regards to training your machine learning model, you have 100 divisions of each of the but what about if there is a class imbalance? How would you...
if there is a...
Class imbalance. So you have like 100 images of something, but only 10 images of another thing.
It's again the problem of, this is the challenge, like how do you make sure that you can source the proper data to train your machine learning models upon? It's like, this is a challenge that we as a human have to face. It's like, your model will perform bad. That's the answer. Like, I can't get a better answer than that. Like, you have to source that data. You can write a good code, but that code is as good only as the data that you provided. It doesn't work in that way. It won't work well. Yeah. Yeah, so let's say there are hundreds and millions of cat images out there. What Google will do is make sure that they don't have lots of those cats and dogs images in there while they're training it. Make sure. So they try to balance all the different types of categories that are out there. Remember this autograph that you guys were doing? This was used by Google to train their models on top of it again and they built out another tool which is called auto draw. This was quick draw, that is auto draw. Based upon how you are drawing, it will automatically draw it for you. You can like go to AI experiments and find it. What happens there is, since so many people drew carrots, might have drawn carrots very different way, it was having a really hard time identifying carrots today. So that it was really having hard time finding out faces today, because people who gave it data, Google didn't like optimize for this. They don't have a lot of team working on this demo example. So it's based on all the people that have given it examples. So people who did this demo before you drew face in a very different way. And now machine knows a face looks very different based on what you are drawing. You are drawing smiley face and it should have recognized that, but it doesn't, because it has been trained upon some other data. So it's all again, you as a user or you as a company have to identify and make sure that you are making comparable differences or make sure you're training properly on the proper data. Do we have people from the other track over here? Yes, people who are in app track? Alright, let's come on and get seated. And we will go to the next link. Alright, this link, please open up your phones, get started on this link. All this feedback that you're going to give now, this is the feedback form. It will go to Google. They will understand how we did today. Did you like it? Did you not like it? Give you raw feedback there. Give you proper comments. Alright, I'll give you a try. Do you want me to play my music? Some music? No? Do you want me to dance? I can't dance. Alright, let's get started on this. Fill up this form. It helps us to understand how to make these events better for you. Like you can say that don't order so many pizzas next time.
We like
or
leftovers.
give those t-shirts for free rather than playing a game. Right?
I want a t-shirt.
Yeah, I know. Or you can tell Josh Gordon should have been here. Or you can say, what? Cookies, better cookies. Alright, I see people are doing that. Go for it. Fill out the form. I don't know how big that form is.
But I'm live periscoping you on Twitter right now.
Ooh, should have done that. Thank you. Hi, everybody out there. If people on Periscope want to fill up the form, thank you very much. That would be great. Yeah, tell us how we did. Alright. Anybody who fills out that form, that's going to Google, not coming to me. I will get the feedback from them, that what you liked. If you want to give me raw feedback, remember these sticky notes over here? I still don't see anybody coming up over here and drawing something. Come on. I would say that there were too many pizzas. Too many.
How about Chevy? I think. I submit the form already.
Too many pizzas. Come on. Somebody, write something.
Everything was great.
How does that work? That's like saying
I know.
I passed my machine learning model, a noodle, it says it's a noodle.
I wish I got a t-shirt.
But that's, yeah. Do you want to get a t-shirt?
Yes,
We
please.
will play a game again. But do people have this link? Do people
Yeah.
have this link? We will play the game again. You remember the game? Remember the game? Yeah. Alright. Alright.
What do you do?
First is her chance. Come on.
Just
Then you can form the line over here.
what do we do? Oh
But
yeah,
first is her
can
chance. Sorry. Come on here. Yep.
What are we doing?
You are playing a game.
Oh, okay.
Alright. Nice.
Like soft?
No. That's no, don't get so. Alright, you remember this game? Remember this game? Yeah, just go. Let me just play it again. Spreadsheet. I have a spreadsheet.
I see shoe, or square, or bench, or pillow, or envelope. I see postcard. Oh, I know, it's spreadsheet.
Submarine.
I see line, or hood, or pond, or marker, or pool. I see pencil, or sleeping bag, or shoe, or hot dog. I see nut.
I don't think I'm good at this.
I see speedboat, or bread, or clarinet, or trombone. I see toothpaste. Oh, I know, it's submarine.
Nice. Good club.
I see magic wand. Oh, I know, it's golf club.
Nice. I'm good at this.
I see share or line. Oh, I know, it's snowflake. I see circle.
I haven't used that.
Or ring, or helmet, or planet, or satellite. I see face. Oh, I know, it's baseball.
Nice.
I think all finished, right? No more,
I see line,
no more
or shoot,
presentation.
or hard,
I don't think so.
or bathtub, or hot tub. I see hockey puck, or bottle back, or pool, or hot dog.
No?
I have no clue what you're drawing.
Yeah, I know that. Even I don't know what this is at this point. It's a couch, come on.
I have no clue what you're drawing. Oh, I know, it's couch.
Woo, found it! Alright, I did all 6 of them. So what you have to do now, since we have everything all done, what do you have everything good? Let's get started. You have to draw it, okay? Okay. Again. People from other crap who did not get straps to the t-shirts or socks, line up. You have to draw it. Yep, you have to draw this guy. Use your hand, it doesn't cost you. But go for it. Let's see if people can draw this.
Or bread, or shoe.
Those who already won, please don't come up on the line. Don't try to win again. Let others have a chance.
I see red, or ball. I see helmet, or helmet, or ball, or I see flowers, or ball, or shoe, or necklace. I see many face, or banner, or book, or laptop. I see outside, or magic bag, or X, or light. I see toothbrush, or ceiling. I see rifle, or line, or pillow, or blue, or bread. I see bun, or hot tub, or shoe, or cooler, or oven. I see pool. I have nothing that will draw. I'm stuck. Sorry, I couldn't I see mirror, or mirror, or necklace, but I know it's there.
Goodbye, handsome man.
See you later.
I know that your girlfriend is saying hi like you.
Sorry?
Yeah, your girlfriend something saying hi like you.
Oh, I don't have a girlfriend. I stay single. Yeah. Have a good day. I'm David.
I'm Sandy. Are you American?
Nope.
Canadian?
Yeah. I'm usually just in the bed.
I should go to Hollywood.
Enjoy the pizza, get more coffee, get more drinks. If you can carry on, very
Better than the first one.
Thank you. Just push it. Push it.
I want a free teacher. Your phone's about to die.
Thank you. It's good seeing you again.
Just one thing. Come on. No. Just one thing. Either the socks or that. One or the other. One or the other.
He wants the socks. Davey wants the socks. No, he doesn't have anything.
No worries. No, he has to play. Come on. No
But it's
cheating.
not working.
It's working. Everything is working fine.
Hey,
Come on, choose
you're
one.
live. You're live on
I'm
camera.
fine. I'm fine with that. Choose one. All right. Thank you. Remember, we will have to lose the menu. Help us clean the menu. Take your cans, put them in trash can. Help us make the menu available to people who are not here on that day. Help us clean the menu.
I see or drawn right or left.
Are you like familiar with
I'm not sure what that is. Sorry, I couldn't catch it.
Alright.
I see wrong.
Okay. Alright, so here. 1, 2, 3, 4. Sorry about that. We'll stop it, we'll have to stop. So at that point, someone find what you want. I want to keep it. For next event, it's just offset for next event. Please give us some feedback. So we're here. All right. That's for me. Last one is for me. I don't need that. Last one is for me.
Swag, 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 swag,
Come on,
swag.
come on, come on. Back your backs. Put on the trash.